ladies, Mrs. Campbell here. So today we're going to continue our journey learning about acids and bases. And today's topic is we're going to talk about neutralization reactions and we're going to talk about titrations. So by the end of this video, you should have a good idea of what a neutralization reaction is and what a titration would be used for. Okay, so to start, right, I just wanted to tell you that when an acid reacts with a base, and it has to be in the right proportion, the resulting solution will be neutral. But why? Why is that? So let's talk about the chemistry behind that. So it's based on this very generic equation here. When we add an acid to a base in the right proportion, what is produced is water plus a salt. So a salt is just another name for, or let's call it a fancy name for a neutral ionic compound. Okay, so if you have an ionic compound, NaCl for instance, and it's mixed in with water, what you end up with is a neutral solution. So it's neither acidic nor basic. So an example of this would be if HCl reacts with NaOH, okay, and this equation is balanced. So these are reacting in a 1-to-1 ratio. What's produced is H2O, which is a liquid, plus NaCl. Okay, so what happens is, and if you remember back to sophomore year chemistry, right, this is a specific type of double replacement reaction. And what's happening is the positive ions are switching partners. So you might remember me even calling that a wife swap, right? So Na and H are switching places. So that on this side of the reaction, right, Na ends up being partnered with with Cl. Okay, so these two guys end up partnered on the other side, which is NaCl, right? And then you have H, which ends up being partnered with OH. And anytime H and OH get together, what is produced is H2O, right? Because H2O is simply this guy here. H bonded to an OH. Right? So it's just an HOH, which is H2O. So that's what happens in an acid-base reaction, right? The positive hydrogen ion is bonding with the negative hydroxide ion from the base, and you're getting that H2O. And then the positive ion that was bonded to OH ends up being bonded to the negative ion that was bonded to the positive hydrogen ion from the acid, and that's where the salt comes from. So it's just a double replacement reaction. Okay, so in order to neutralize, in order to fully neutralize that solution, the reaction has to have equal amounts of H plus and OH minus ions, because those add together to produce water. So this is what's needed for neutralization to occur. Equal amounts, and those amounts would be moles. Okay. So the moles of H plus and OH minus have to be equal to one another. So let's take a look at an example here. So let's think about this example. How many moles of NaOH would be required to neutralize H2SO4? Okay, and you can get this just from balancing your equation or looking at, all right, how many H's do I have in this in the acid? So this would be a diprotic acid, if you remember, because we have two H's. So we are going to need two OH's to balance that out. Okay, so for every H, we need an OH. And in this case, we have two H plus ions in H2SO4 and only one OH in sodium hydroxide. So what this equation is going to need is it's going to need 2 moles of NaOH for every 1 mole of H2SO4. So it's kind of like thinking back to stoichiometry and our mole ratios almost. but we're really just focusing on those H plus ions and those OH minus ions. So just based on this formula, there's only one OH, so we're going to need 2 moles of that to balance out 1 mole of H2SO4. Okay, so that brings us to this idea of a titration. So what is a titration? Okay, so titration is a process where a known amount of solution, an acid or a base, of known concentration is used to determine the unknown concentration of another acid-base solution. Okay, so let's say we had a known amount of acid, right, with a known concentration. We would be able to use that to help us determine the concentration of an unknown base solution. So the solution of known concentration would be called the standard solution. All right, and then the other solution we would just call the unknown. And this is where last week you learned about what indicators were and what they were used for. This is when the indicator comes in handy. So the indicator is added to that standard solution so that when we start adding our known, our unknown, we are able to detect when neutralization is reached. So neutralization is reached at the end point of the titration. So the end point should occur when moles of OH or moles of H plus that's a plus sign, are equal to our moles of OH minus. Okay, so because remember, it is the concentration of H plus ions that makes something acidic. It is the concentration of OH minus that makes something basic. So if you're able to get all of those H pluses that are in solution to bond with all of the OH minuses that are in solution, they form water and it becomes neutral. Okay, so this is what a titration apparatus would look like. All right, so your solution of known concentration goes into the Erlenmeyer flask, so that's this guy. I'm sorry, the solution of the unknown goes into the Erlenmeyer flask, and your known solution or the standard solution is in the burette, which is this guy. So sometimes you guys pull these burettes out of the desk drawers and you're like, what are these used for? So that's what these are used for. These are used for titrations. So as you slowly add an amount of your standard solution, right, you're able to read, because these have the little markings on them, the volume markings, just like a graduated cylinder would, you're able to read how much acid or base of that known standard solution was added to neutralize your unknown sample that you're trying to analyze that's in that flask. And how do you know? You know that occurs when you see this changeover in color. So these changeovers in color from the indicators, as you learned last class, are what indicate when something turns over to a different pH. And in this case, this is phenolphthalein. Phenolphthalein is used to indicate when something goes from acidic to basic. Okay. So how many moles? So this brings us to some titration calculations. How many moles of sulfuric acid, right? That's this guy. So sulfuric acid, let's use our highlighter so we know what the names of these substances are. Sulfuric acid, which we should know anyway because acids start with that H. How many moles of sulfuric acid are required to neutralize 0.50 moles of sodium hydroxide? So this is our sodium hydroxide. And just like we talked about on the last slide, we need 2 moles of sodium hydroxide for every 1 mole of sulfuric acid. And again, it's because sulfuric acid is diprotic. And in the formula for sodium hydroxide, there's only 1 hydroxide ion. So we actually need 2 moles of this for every 1 mole of this in order for those H pluses and OH minuses to be in the same ratio. So the mole ratio of H2SO4 to NaOH is 1 to 2. So all we have to do is multiply our moles of NaOH, 0.5 moles of NaOH, times this mole ratio, so 1 mole of H2SO4 over 2 moles of NaOH. And if we take our 0.50 and we divide by 2, what we get is 0.25. I really apologize for my handwriting here. 0.25 moles of H2SO4. So that's how many moles of H2SO4, that's an S, would be required to neutralize. I'm actually going to make that look a little nicer. That given moles of NaOH.